Hello students, welcome back. In this video, we are going to put the finishing touches on Broshi. These are going to come in the form of visual game polish. We're going to implement some new visual systems that are going to make our game just look a little bit better, be more fun to play, and be more engaging. And they're going to come in three main forms. First, we're going to add a particle system. Anytime we clear a block, we'll have the blocks explode into colored particles that correspond to the color of the blocks that were destroyed. Second, we'll implement a freeze timer so that when we do a Broshi clear, we have a sandwich, we'll pause the game for a small amount of time, almost call it like a hit stop or a hit freeze to give a little bit of added suspense or build up. And then third, we'll implement a warning overlay to our screen if our columns are getting too close to that top row, meaning a game over is about to happen. So we'll give some visual feedback that the player's got to make some quick moves. So let's head to the computer screen and we'll dive right into our lesson on visual game polish. So I have lesson 8 starter file open here in vscode.dev. I'm going to minimize my browser though and open this file directly. So I'm going to come to my Broshi tab, I'll go to lesson 8 and our starter file. So right now, let's see if we have any of these systems in place. So if I build a, we'll build a Broshi sandwich. We'll check that out, see if we get a nice hit freeze and some particles on our clearing. So we just got it, there we go. So let's see. Any hit freeze, any particles? None. So that was immediate, no particles created, which tells me these systems are probably not in place. I probably don't have a warning overlay either when we hit the top of our Broshi window. So let's go to our code and let's see how we can implement these systems. Mission number 1 in our mission checklist says we need to define our polish constants. Okay, we're adding new systems to this game, so we should probably create some knobs or dials that we can turn to finely tune or adjust this system. These come in our student edit zone, the place where we can adjust values to change how a system looks, plays, or feels within our game. And our visual systems are no different. We have a bunch of constants here for our particle system. If we look, clear particles per block. How many particles are we going to create for each block that we clear? I'll create more than one. Let's do 14. Then we are randomly going to create particles. So we're randomly going to set their speed, their lifetime, how long they are on the screen for, and their size. So for each of these, we will set a minimum value and a maximum value, and then randomly select from that range. So for my speed, I'll set my minimum to 140, and my max will be 600. For my particle life, my minimum will be 0.28 seconds, and my maximum will be 0.90 seconds. And then for my particle size, I'll say minimum of 4, maximum of 10. Perfect. So there are our constants for our particle system. Let's look at our hit freeze system. So when we get a Broshi sandwich, we clear with our Broshi blocks, we are going to freeze the screen for a small interval of time. 1 second is a long time. Let's do it for 0.33 seconds, or about a third of a second. And then lastly, we are going to display an overlay warning when we get close to the top row. What do we want that threshold to be? Right now it's set to 1, so that's like 1 row away from our top row. If we're 1 row away, that's like super dangerous. I'm going to start warning them when we're at least 2 rows away. So let's set our warning threshold to 2. All right, mission number 1 is complete. Those constants for these 3 systems are defined. So let's go see what else we have in this new visual system setup that we have. In our color palette, it looks like we have a warning color, all right, RGBA, and we have a swap color. Ooh, were we implementing a swap color as well? Look at that. That's some new visual feedback right there. So that's brand new. As we move here, we now have our lanes highlighted for what columns we are going to potentially swap. So that looks that's really sort of nice here. So that is something that's already been done for us here, and we can look in the code and try to figure out where that is happening if we have time to at the end of this video using our swap highlight color. In fact, let's just do it right now. Let's hit Control F to search for swap highlight color if we have it highlighted here, and we can go down and it looks like we have a new function called draw swap lane highlight, and that's exactly what we're doing here. We're getting the player swap swap lane, and then the swap lane plus 1. And we've seen that. This is the left column. In the right column, we're getting an invisible marker, and we're filling our paint bucket with the swap highlight color. And then we're drawing a couple of rectangles that correspond exactly with those lanes that we have highlighted. So that is very, very cool. Let's go back though and keep looking at the constants that we have. So we have a warning color that we'll probably use for our warning overlay. It's going to be primarily red here with a transparency of 0.25. So we're going to be able to see behind it quite a bit. Now let's look at gameplay variables. Any new gameplay variables? Well, every time we clear a block, we are going to create 14 particles. We're going to need a place to store all those particles, especially if we're making multiple blocks at once being cleared. So we have an array for all of those particles that we'll store them in. I have a timer for my hit freeze. We are eventually going to set this to, I believe it was 0.33, and then we'll count it down, 0.21, 0.31, 0.3, 0.2, 0.1, and when it hits the 0, we are no longer freezing. So we'll have that available to us. And then we have a Boolean variable called stacks are in danger. It's set to false, and if those stacks get too high, like 2 rows away or our threshold away from the top, then we will set this to true and probably use this to draw our warning overlay. All right, those are our visual systems. So let's go to mission 2 now. We'll type it in our search bar, and mission 2 finds us in reset game to defaults. This is where we reset all of our systems. So we reset our player's position, we reset our columns and active blocks, we reset our score, our runtime, our ramps. Now we want to reset the polished systems. Because imagine if we died and there were particles on the screen. If we started a new game, those particles would still exist because they were in our array. We got to empty that array out. So we will type the name of the array, particles, a nice tab for autocomplete, equals a blank array. Now it is completely empty on the start of a game. And we should probably do the same thing just to be safe for our other systems. So I'm going to do hit freeze, timer seconds, tab for autocomplete there, is equal to 0. We'll wipe that out. And let's set our stacks are in danger. Stacks are in danger equal to false. Because when we start a new game, we're not in danger yet. We have no blocks in any of our columns. All right, mission number 2 is set. So now let's go target one of these visual systems. Mission 3 finds us targeting the generate particle data function. All right, when we generate particle data, we're going to take in an X value, a Y value, and a particle color. Because if I clear, let's just see, maybe I can clear. Okay, so I'm going to clear. If I clear these blocks, I need to know exactly the X coordinate and the Y coordinate of where I am going to generate particles. I also need to know the particle color. Well, that's going to be the color of whatever block I destroy. And so if we look here, I have generate particle data. And then we are spawning particles and updating particles. So anytime we introduce something into our game world, we're going to generate data for that something. We are going to spawn that something, and we will update that something. We are doing all 3 of those things right here. Now, when we generate particle data, we get access to an X value and a Y value. And we can see we have them set right here. Our X property of our particle. Our particle actually has a lot of properties. It has an X property, a Y property, a Vx and Vy. Those are our horizontal velocity and vertical velocity. A life and a max life, a size and a color. We pass in X, Y, and color and set those to our properties. But look at what we're doing here. We've got angle is equal to 1, speed is equal to 1, life is equal to 1, size is equal to 1. That just does not at all seem correct. So we have to change these things up. Let's first talk about some of the easier ones, like speed, life, and size. We know every particle needs to have a random speed, and we have set the range in our constant system. So we will use random, and then we will pick from particle. Was it particle? Let me see. Was it particle? What did we name these constants? Clear particle. That's right. So we'll say clear particle. Let's see. I want speed. I think this is going to be my last 2 in here. So if you start typing clear in your autocomplete, we're going to do the final one right here. Clear particle speed min all the way to clear. And now go to your second to last one is going to be clear particle speed max. So we'll randomly select from a speed of 140 to a speed of 600. Let's randomly select our lifetime. So we'll do random. And we'll type out clear. And this is going to be our second item in this list, clear particle life Oh, I got that wrong. Clear particle life min. And then we'll do clear particle life max. This will be our third one, right? Oh, I got that wrong. Max. There we go. I don't know how I'm getting those wrong. Well, there you go. Clear particle life min and clear particle life max. So we'll randomly select from 0.28 seconds to 0.9 seconds. And then we need our size. So we'll randomly select from clear particle. Let's see if I can figure this out. This was speed. So size is going to be size min. This should be size min, our third one from the bottom. Hey, and I got that one right. Perfect. And then clear particle size max will be our fourth one from the bottom. So count up 1, 2, 3, 4, and there it is. So we now are setting our speed, speed here, our life, and our size. Now max life is going to be equal to life, and then life is equal to life as well. So if we say, hey, our life is going to be like 0.9 seconds, we're keeping track of the total life in max life, and then we will decrease the life property. So we'll go 0.9, 0.8, 0.7, 0.6, and then we'll get it to 0. But we're keeping track of that starting value just in case. Now let's talk about angle here, because you can see I'm using angle in the horizontal velocity and the vertical velocity. So I somehow have to get that. And so an angle, when we think about degrees, and maybe I'll go to the whiteboard here. I'm going to draw a little bit of this out just to help us. Like an angle in degrees could be anywhere from, let's draw like an axis. Could be anywhere from 0 to 360, right? And if you think about 360, going 360 degrees makes a circle. So that's a full circle, right? So that's 360 degrees, or starting point of 0 degrees. This would be 90 degrees, 180 degrees, 270 degrees, and then 0 degrees. But we have a whole other system outside of the degree system known as radians. And in radians, this is going to be, let's see, 0 radians. This is known as pi over 2 radians. This is pi radians. This is 3 pi over 4 radians. And then coming back, completing a whole circle is 2 pi. So we are going to generate an angle from 0 to 2 pi. Let's randomly select. So that's going to be like our 0 to 360 degrees. It's just that sine and cosine here, these functions require radians. So we are going to give it radians. So we'll select random. And then this is such an important angle, it's given as a constant, 2 pi. Now, how do we use this angle to determine a random horizontal velocity and random vertical velocity? Well, let's start by just assuming that, our speed is, we'll say 600. If our speed is set to be 600, let's see how an angle can give us the horizontal and vertical values. So let's just say I have a particle, here's my particle, and I want it to shoot off in this direction, one off in this direction at 600, okay? So if we look here, there is a horizontal part to that arrow, we'll call it Vx, and there is a vertical part to this arrow, we'll call it Vy. And there is some angle right here, theta. So there is a relationship that relates all three of these sides. This side right here is known as the hypotenuse. This is the adjacent side to our angle, and this is the opposite side of our angle. And so the trig relationships here says that the adjacent side and the hypotenuse are related through the cosine of your angle. So the cosine of your angle is equal to the adjacent side, which is our horizontal velocity, over a hypotenuse, which is our speed. So if I multiply both sides by speed, I get Vx is equal to the cosine of theta times our speed. And that's exactly what we see right down here. And Vy is going to be given as our opposite side and our hypotenuse. That relationship is known as sine. So the sine of theta is going to equal Vy over our speed. And so multiplying, I see that Vy is the sine of theta times our speed. So as our angle changes, the cosine and the sine of the angle are going to change as well, and we're going to get different amounts of Vx and different amounts of Vy. For example, if I drew another arrow that had a size of 600, but I drew it this way, all right, you can see the horizontal component of the arrow, or the horizontal part, is much smaller, while the vertical part of the arrow has gotten much bigger. And that is because this angle is larger now. So that's how we're going to randomly shoot our particles off in all different directions. So it looks like we've generated our particle data. This is pretty good. Here is our particle object. Let's see if we run this, will we get any particles when we clear a Broshi block? Let's see, yellow, blue. I just got to get two okay, blue and blue. Let's see, anything? Keep your fingers crossed. Nothing. Oh, bummer, 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 bummer. Well, we have this particle data, and if we look, when we call this function spawn particle, which takes in a column, a row, and a particle color, we are pushing into our array particles whatever is returned from the generate particle data function. So what's the problem here? It seems like things are wired up. We might not be spawning particles yet. And if we look at mission number 4, it says, okay, we got to spawn particles when the blocks are cleared. So this is going to push us into resolve block landing. So right here, we ask a question, hey, do the colors of our top block in our column and our current block match? And are they both color blocks? If that is the case, we are going to now spawn some particles because we know we are going to clear those 2 blocks, right? We're popping them. We're adding our score success. It's time to spawn particles. So we are going to do spawn particles. And we need a column, we need a row, and we need a color. So our column, well, if you look here, we have a column right here. It's stored right here as a variable. We'll do col. So we'll do column. We need a row. The row we are in, we don't have directly here, but you see how we got column through block.col? Our blocks have a column property, I believe. Let's just go look. Right? They have a column property, but they also have a row property. So the block is going to keep track of where the row is. So let's reference our block, and we'll pass in its row property. So block.row, and then we need a color. So we'll do block.color. All right, let's see. Let's see this in action. Now we should actually spawn some particles. All we got to do is just get a match. Let's see. All right. Well, it worked for Broshis. They're sort of special. Hey, look at that. We got green and green. All right. So that looked pretty cool. So here's our purple. So that's not too bad. That's not too bad. But you know what? It sort of looks like I want to spawn, because I think right now we're only spawning for one of the blocks, right? We're only spawning for one of the blocks, but what I would really like to do, I think, is spawn particles for both of them. So let's just see, like, if I can move it up here. Where are those particles spawning? Are we spawning some here and here? It's sort of, I don't know, it's hard to tell. Let's actually spawn particles again. So we'll do spawn particles. And we'll do in the same column, but this time we're going to do block.row plus 1. We're going to go to the next row, and we'll do top block dot color. We'll get the top block's color. They should be the same, but let's just check. Let's see, how's this look? This might aid in us when we do our Broshi clears. Let's check. We just got to get there. We just got to find some matches. Thankfully, we got that soft drop. Okay, so here, now we should have double particles. Let's just see. Okay, so that looked better. Let's test it with a Broshi sandwich and see if this works for everything in a sandwich. We just got to get one more green block. There it is. Okay, oh, I got to get there. All right, let's see. Oh, that looked great. Everything cleared there. That was perfect. So I think I like that. We're gonna spawn particles at the block that we cleared and the top block. So we'll do both of those. All right. So I think our particle system is working pretty good. So what we're gonna do now is move to our hit freeze trigger, because when I clear a Broshi sandwich, I want to slightly pause my game. So if you look here, this finds us in check Broshi clear. We've worked through this function before, and we know that if we get to this point, we have cleared a Broshi sandwich. We just added all of the score to our score bonus, and we cleared out all of the blocks in there. But now we have that hit freeze timer seconds. It's currently set to 0. Well, I should trigger that timer, and I'm going to set it to the constant for this system, which is hit freeze seconds. 0.33 seconds. So we'll set this timer. So now what do we do with this timer? So this timer is active. We have to use it to sort of pause our game loop. So if you look at mission number 6, it says use the timer to freeze gameplay briefly. And this is going to happen in our draw function, that function that's getting called every frame of our game by the P5 library. So the first thing we do is we get DT, right? How much time's elapsed in the given frame. And then we ask, are we currently in play mode? Because if we're in play mode, we've typically been running our timer, updating our ramp, updating our player, our blocks, our particles, and now we're also updating our danger warning status. But now we are going to ask another question. See, we only want to update all of that stuff if our game is not set to freeze, if our freeze timer is not set. So we have to ask a question. If our question is true, we are going to decrease our freeze timer. We're going to count it down, 0.33, 0.32, 31, 3, 29, 28, all the way down to 0. And then we will constrain it to make sure it does not go below 0 or out of the hit freeze seconds of 0.33. And then once it reaches 0, we can go back to running our game. So let's ask that question. We'll say if hit freeze timer seconds is greater than 0. If there's some time on it, let's decrease the time and not run anything in our game. This is going to create like a nice stop freeze effect for us that's going to be just short-lived enough to give a little bit of tension to the game. So let's see if we can create a Broshi stack. All right, a Broshi sandwich coming up. Got one slice of bread, just looking for the other slice of bread. Those block. Okay, here we go. So let's see. As it falls, we should freeze our game slightly. And oh, we get that explosion effect. So that's pretty cool. The particles get drawn to the screen, they wait, and then they explode. So I really like that hit freeze. And it stopped that falling block too mid. So that effect is working perfect for me. I'm very happy with that. So our last visual system involves the overlay trigger. So mission number 7 finds us in draw scene. We know draw scene is getting called every single frame of the game. We are drawing our background, our drop zone, our blocks, our particles, our player, our HUD, and our overlays if certain conditions are true. Well, our danger overlay is no different. So we're going to say if, and then we got to ask a question. And if that question is true, we want to do something like draw our warning overlay or draw our danger overlay. So it looks like we have, what functions do we have here? Draw ramp readout. Ooh, okay, right here, draw danger warning. So we're going to want to call this function. This function is going to draw our warning overlay. So let's go back to mission 7. And if this specific question that we're going to try to figure out is true, we are going to call draw danger warning. Name it, parentheses to run it, semicolon for good JavaScript. So what is the question that we are going to ask? It's got to be a yes or no question, something that is either true or false. I think we have a variable for this system that is either going to be true or false, and that is stacks are in danger. When we set it equal to false. If I double click it to highlight it, I'm going to hit Control F. I have 4 instances of it in my program. Let's go see where they are. Here, we initialize that gameplay variable to false. All right. Then, I think when we reset our game to defaults, we make sure it goes back to false. So where's our third instance of it? Our third instance of it is in update danger warning status. And it says, hey, stacks in danger. If is equal to the highest occupied row, if it's less than warning top row threshold. So you see right here, we get our highest occupied row by looping through every column, and we check our first empty row. Perfect. So now we have a way to update if our stacks are in danger. Now, let's see if that actually does anything for us. So I'm just going to spam this. Let's just let a stack build up. All right, I just got to bring it over. Bring this one over. Oh, better not do that one. That would make a Broshi sandwich. That would remove everything for us. Keep it going. Keep it going. Nope, not falling for that one. Get this one, though. Yep. All right, couple more. We're approaching our threshold, so let's see. One more, and we should be at our threshold. All right, so there is our red overlay, our warning overlay. So it's just drawing it right now, which I guess is okay, but I'd prefer it if it like flashed, like danger, danger, danger. So what we have to do is we have to sometimes draw it and sometimes not draw it. So let's go see at what is happening in mission number 8 to create that flash effect. It puts us in our draw danger warning. And so let's just look here. We grab an invisible marker, we put some paint in our paint bucket of our warning color, and then we draw a rectangle that sits over our game window. Well, we're saying if false, return. Return means get out of this function so you don't run anything else in here. We skip this code, but we're always saying false, so we never actually run that. So what we're going to do is we are going to, let's test a few things here. We're going to test, let's put runtime seconds. So, and I'm going to call the floor function because runtime seconds is going to be a decimal. So it's going to be, it could be like, 1.1, 1.2, 1.9. What the floor function does is it just chops off the decimal. So you only get the whole number. So it'll just be like 1 second, 2 seconds, 3 seconds, etc. And I'm going to check to see if that is divisible by 2. And so this right here, this percentage sign is called the modulo operator. It checks to see if something is divisible by something else. And if it's divisible, that modulo would equal 0. So if runtime seconds is 1, not divisible. If it's 2, divisible, this is going to be true and we'll just return. If it's 3, not divisible. If it's 4, returns 0 because it's true. Oh, I said I was going to call the floor function, wasn't I? So I got to call the floor function on this. So we'll call floor. So we chop off that decimal. All right, so let's test this now. Let's see what is going to happen if we get a nice flash effect. I'm going to restart the game. I'll pause the video to build up my column so you don't have to watch me. Okay, so I got my column here coming up pretty high. We're about to hit that threshold. Let's just see. Okay, here it is. All right, so hey, look at that. It's flashing. It's not urgently flashing, though. It's flashing super, super slow. And I think we can speed that flash up. So the way we're going to speed it up is we're going to multiply runtime seconds by some integer value. The bigger the number we multiply here, the faster it is going to flash. I'm going to multiply it by 8. We'll give that a shot. And I think with that, our game is complete. Before we do one final test, though, you see how I still got my ramp readout shown here? We are now officially done. So I'm going to get rid of that ramp readout. I'm not going to delete this function though, because I might want to bring it back. So all I'll do is inside of the draw HUD function where we call draw ramp readout, let's just comment it out. We'll just put 2 little lines here, /, and now it won't run. And with that, Broshi is complete. Let's do a final playtest. Let's check this out. So we have the ability to do our soft drop. I can maneuver through our columns. I have a highlighted column swap lane. We get particles on our block clears, which looks wonderful and is super great. We have Broshi stacks. I'm going to get a nice Broshi stack sandwich right here. Let's get it going. All right. I could clear that one, but I'm going to keep it. That worked out perfect. All right, let's put our blocker right here because I'm going to destroy it with a Broshi sandwich pretty soon. Just got to wait for another top piece of bread. Oh, let's do this one. Oh my goodness. Am I not going to get another? Oh, there it is. I got to get there. Let's see. There's that hit freeze. All right. I really like how that looks. So that whole system is working good. And let's keep playing it. Let's see. All right. So eventually our ramp is going to be filled up. We should be spawning more and more blocks each time. So eventually we'll get to spawning 3. And I'm going to build it up to see about our flashing overlay now. So let's just take a look. All right, so we're getting there. We're getting close. We should be hitting 3 on our spawn anytime soon. Okay, so there's 3. So that worked out nice. And we're okay. So this time we should see our flash, and there is our flash. Our flash looks much better now. Does that flash shut off if we? I gotta. Yeah, it will shut off. I know it will shut off. I can't play it because I'm so bad. Oh, there we go. So I sort of cleared that one. Not that one though. Oh no. Oh no. This is no good. Yeah. Oh no, that's why we put that right at the end of the game. It says, oh no, because that is exactly what you say as you're playing Broshi, and those stacks keep getting higher and higher and higher. I got to say, this is a really, really fun game. It looks great. It plays great. And it's really addictive to keep playing to see how many points you might be able to score. And, you know, it balances this like risk reward really well. Do you risk it by building a huge sandwich stack for Broshi to eat to get lots of points? Maybe you do, but maybe you don't, because you saw in that video right there at the end that it came back to bite me. So with that, I think this is a great place to stop, and I'll see you in our next video.